Thank you, Dahlia. I can do this. It just goes up late. So voltmeters and ammeters, they're the symbols, but what do they do and how do they work? First, I want you to turn to your classmates and discuss the same stuff that we've been saying for the last 3 classes. What's current? How does it behave? What's voltage? How does it behave? In particular, how does it behave? I mean, the principles of how does this thing split up or maintain equality in a series and parallel circuit? What are voltage and current and how do they behave? Ready, set, go, turn to your neighbor. I'm giving you 3 minutes by the clock. Review. Hey, what do you know? Tell me something about voltage or current. Just shout it out. What's the defining equation that's always true for voltage? Something that is always true, always, always, always true about voltage. This may be a test question. Oh, you don't know anything. You don't know the first definition of voltage. Oof. Maybe you're just shy. Put it in Google Question A. Let me see how many people are shy versus how many people don't know the definition. The defining equation that is always true for voltage. Oh boy. State the equation which defines the quantity. You can define physics terms in form of their equation. I define velocity to be delta x over delta t and so on. Oh, Jesus. Well, here's where we're going to start. And I've got a new test question to put on. Okay, so what is the resistance of a battery? Does a battery have an ohmage? Does a battery have volts? Then how the hell is V equals IR the defining equation for voltage? That's only true if there's a resistance. Batteries don't have resistances, but they have voltages. V equals IR is exactly the wrong answer. V equals IR defines R. Resistance is the constant of proportionality between voltage and current in a resistor. V equals IR does not define V. It is not the essence. It is not the meaning of V. There will be 1,000 different voltages that we will do in this class, not really, but many voltages we will do in this class, and you must know that V equals IR applies to one of them, voltage in a resistor. Try again. Question B. Try again. Make a second pass. There were people who got this right, but most of you said V equals IR. No. What's must? 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 Oh, that's more like it. More like it. More like it. Okay, so here, principle numero uno. No, I should use English. Nice big bold letters. I introduced voltage like half an hour to an hour worth of class before I introduced resistance. Let me remind you that that part of the semester existed. Voltage exists even without a resistance, even without a current. A 9-volt battery that is disconnected is supplying no current, and that doesn't make its voltage stop existing. What is true is that every coulomb worth of charge, remember how we measure charge? Every coulomb worth of charge has 9 joules of energy in a 9-volt battery. The point of a 9-volt battery, of any energy source really, is to deliver electrical pressure, electrical energy, electrical impetus to do stuff into the charges that make it up. So remember this. I'm writing this as a test question now, not like literally this, but this concept. You must know this. V equals IR is not the essence of voltage and does not always apply in electricity and electronics and such. Voltage is defined by the idea that it is the concentration, the density, the intensity of the energy spread over charge. Okay, so let me ask you this. How does, I don't want to do question C yet. Current's meaning is not voltage divided by resistance. Current's meaning is how fast the charges are flowing. Charge per time. Yeah? Deja vu? Literally the first thing I told you? Okay. The flow rate of charge. Okay, so let me ask you this. We've got a voltmeter, we've got an ammeter. We want to measure the electrical pressure of something. We want to measure the flow rate through something. Tell me, this is a circle the correct answer. This would be question C, and this would be question D. This either must or must not. Fill in the blank. What does it make sense when the electricity, if I'm trying to measure something, what does it make sense for the internal resistance to be? Hmm. 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 I have a 9-volt battery. I have a voltmeter. Ugh! Oh, wait, sorry. That's an old meme. You guys don't know that. Never mind. Pen, pineapple, apple, pen? Yeah, you do remember that? Okay. Pen, pineapple, apple, voltmeter. No. I have a 9-volt battery. I have a voltmeter. If I connect that voltmeter and it shorts out the battery, is that a good thing? That's a bad thing. If a butt ton of current flows through a meter, a bunch of current through a voltmeter would disturb the voltage levels present in the circuit. For instance, here's a circuit we're going to discuss in a few minutes. This is called the voltage divider. It's a very fancy name for a very simple circuit. Where does the current flow in this circuit? Current leaves L battery, flows down through resistor 1. If the voltmeter drew current, then the current would split. Would you really be measuring the same current, same voltage, as if there were no voltmeter there? Adding the meter shouldn't be allowed to change the measurement, right? If I use a ruler that magically shrinks things that it's next to, am I measuring height? No. So a voltmeter that draws current would disrupt the electrical voltage levels present in the circuit. That's bad. A voltmeter must never allow current to flow. In practice, modern voltmeters have 100 million ohms of equivalent resistance. We are very good at building voltmeters that allow basically squat through them. Ammeters. I want to measure how fast current is flowing. Should that current flow through me or beside me? Through. Absolutely. If I want to measure how much current there is in a wire, how do you do that in lab? Have you measured current yet? How do you do it? How do you hook your ammeter? How I tell my lab students is, if you want to know what current is in a wire, remove the wire, replace it with the ammeter leads. The ammeter is part of the circuit. If you want to know how much current is flowing, that current had better darn well be in the meter. Memorizing is necessary for some things, but this is not something you should memorize. I want you to turn to your classmates and discuss why it's important that a voltmeter can't disrupt the voltage levels, why it's important that the current must actually be forced to flow through the ammeter. If you know the whys, this isn't something to stuff your brain space with, and you'll know more about voltage and current. Ready, set, go. I have an answer. Yeah, I'm giving an introductory thing, and yes, I'm telling you the answers. Merry Christmas. I mean, if you can internalize and regurgitate them to me, it's not exactly the same, but I'm going to tell you this is the closest thing, this is the closest possible study guide. No, not that close, but I will give you a circuit that looks just like this and ask you to analyze it. Fine, if I teach you in class right now how to find the current, in the test I'll ask you to find the voltage. Exactly. You're welcome. Okay, so you feel comfortable thinking about why ammeters flow current through them and why voltmeters have to measure without drawing their own current, without disrupting the flow through the original circuit. Here is a correct way of measuring voltage across a resistor and current through a circuit. Tell me this, Google question E. Series, parallel, or neither with this resistor? Is the ammeter, excuse me, series, parallel, both, or neither? Ammeter and top resistor. I define series as what? No other path? Connected but no alternatives, no route, no junctions, no splits, no alternate routes. Whatever leaves that battery had better damn well flow in the ammeter, had better darn well flow through the first resistor. Series, connected, no choices for the current. What's parallel? Connected at both ends, directly connected at both ends. So, for instance, this battery is touching this resistor at this point. There is an all-wire path between negative terminal of the battery and this resistor. Does that mean it's parallel? Yes or no? Google question, what are we on? Google question F. Is the battery in parallel with the lower resistor? Again, the parallel definition is things are in parallel if they're touching directly at both ends. Is the battery in parallel with the lower resistor? Oh, good-ish. The correct answer is no, niet, ni, nichts, nein. Or as we say in Spanish, no. They are connected at what end, but they must be connected at two ends. At least that's what she said, right? This end, is this end touching that end of the battery? No, 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 not connected in parallel. This voltmeter is connected in parallel to the lower resistor because his top end touches his top end with wire and his bottom end touches his bottom end with wire. Yeah? What's true about voltages of things in parallel? What is always true for voltages in two parallel components? We made that little table last time, yeah? They are the same, they are identical, they are exactly equal, they are the same volts. Okay, so sure, I'll wiggle. I'll do the wiggle. Yeah, so we have two components here which are in parallel. The lower resistor, you know what, so I can say this in words. I'm going to give these names, R1 and R2. The voltmeter is in parallel with R2. It's really important that it is because voltages in parallel are equal. By sort of, maybe you could define parallel as that. What about the ammeter? If you want current to flow through it, does it be in series or parallel? Does it be? I can't good English. It must be in series. This is the correct way of hooking up meters. Ammeters in series, voltmeters in parallel, and something in series with the ammeter, otherwise you'll blow the ammeter up. Don't do that. Okay. Let's analyze this circuit. Numbers. People like numbers. Numbers are good. Numbers are great. I got a 24-volt battery and a 6 ohm first resistor and 4 ohm, I'm making this up, second resistor. Your task is to tell me question G, what does the ammeter read? Question H, what's the voltmeter read? So question G, find that. Question H, find that. You may work with each other. This is two questions on the midterm, by the way. Not exactly, but if you can do this, you can do that. What unit do we measure with amps? Oh, So why are you guys telling me G in volts? The answer to what does the ammeter say is not volts. And vice versa. If I ask you what a voltmeter says, you should tell me a number of volts. If you're confused, I also recommend you walk through Tucker's patent pending process for analyzing any compound resistor circuit. We went over this last week. Combine series and parallel resistors. Find total current. Jiggle V equals IR until you find the voltage and current with whatever you want. Oh, a correct answer. Ooh, multiples. Ugh. Lots of correct answers. Give me the shivers. Yeah, I only have 30 responses so far. Okay, like 30 more seconds. Okay, time's up. I will walk you through how you should think about this. What your knee-jerk reaction should be. I have a 2 resistor. I have a multiple resistor circuit. I find the total. How are these connected? Series or parallel? The voltmeter doesn't break the seriesness. The voltmeter is effectively an infinite ohm resistor. If no current can flow through V, remember how I defined series. No choices. Current can't go here. Remember what I also just said about the nature of voltmeters. They mustn't be allowed. They don't change the voltage levels in the circuit. If this sucker drew current and this guy doesn't have as much as before, well, that would be changing things. So this is a series resistor circuit. R1 and R2 are absolutely positively in series. 10 ohms. 10 ohms of resistance. Step 2 of Tucker's patent pending process was to find the total current. If you know that the total resistance is 10 and the total voltage is 24, what's the current? 2.4! 24 divided by 10. Okay? If I know the current leaving the battery how much of that current enters this ammeter? Google question Google question I. If 2.4 amps of current leave the battery, that's the total current, how much of that enters the ammeter? Good, 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 good. Good, bad. Lots of goods. Okay, I'll take that. I will hope that the rest of the class remembers that current cannot leak out. Current is stuff, and that stuff doesn't disappear. If a car enters the bridge tunnel underneath Central Phoenix, that car is going to exit the bridge tunnel under Central Phoenix. Traffic doesn't just disappear, neither do electrons. If 2.4 amps leave the battery, 2.4 amps pass through this ammeter, which also should make some kind of sense. If this were just a wire, 2.4 amps would flow through this wire, through the resistors. Since there's an ammeter that acts like a wire, still 2.4 amps. Okay, 2.4 amps enters resistor 1, flows through resistor 1, enters resistor 2, flows through resistor 2. How could you find the voltage in 2? Well, I know the total current, and I know that current is the same in every series component. This is effectively not breaking series, remember? If I know the current in this and the resistance in this, knee-jerk reaction, what do you immediately know? You know the current through it and the resistance of it. So what does that give you? Bada bing, bada boom. Use Ohm's law to find voltage across it. 9.6. If you said 9.6 for question H, give yourself a pat on the back. So the correct answers were 2.4 amps and 9.6 volts. You do need to know the units, by the way. I'm not penalizing anyone for not putting the right units, but like we've been talking about this since the beginning, and if you don't know that voltage is measured in volts, there's a problem. You need to study more or something. Do something different. Okay, now I would like to point out, incidentally, a fun numerical fact. 9.6 volts compared to 24 volts. What percentage is the voltage? Anyone with a calculator grab 9.6 divided by 24. Oh, I'm going to do it in my head. Is it 0.4? Oh, how'd he do that? Let me ask a second question. What fraction of the total resistance is 4 ohms? Wait, I'm going to do this one in my head. 4 out of 10 is 0.4, right? This is always true with this circuit, the voltage divider circuit. You could say this as a single, short, easy phrase. The voltage across each resistor, the voltage across each resistor is the total voltage times that resistor's fraction of the total resistance. So you can say voltage of resistor 2 compared to the voltage of battery is the same as resistance 2 divided by the total resistance. The voltage of resistor 2 is the voltage of the battery times resistor 2's fraction of the total. What equation did we just use? What equations did we just use to find initial current? Total current comes from where? Did you not use 24 volts divided by 10 ohms? That's this. You did VB over total resistance. What did you do with that total current? You know the current goes through that resistor. You multiplied. This is I times R. So 2 resistors is a redonkulously dinky little circuit. Nevertheless, it is a very important subcircuit, a chunk of lots and lots of real-world circuits. There aren't many two-component things that people actually use, that care about. Most circuits have, that's ridiculous. There are so many different kinds of levels. On the level of circuitry that I am interested in, able to analyze and build and stuff myself, 100 components are common, and there are at least a couple of combinations of two resistors in there. Compare that to the other subsections might have 20 components in various topologies. So it's probably the most common individual kind of little subcircuit in my kind of electronics. I'm not an engineer, but to my experience. Okay, so do you feel comfortable with being able to find the voltage across, the current through these? Let me test your understanding of voltmeters and ammeters. What happens what would happen if I did this? If I hooked it up wrong? Google question JK rolling. No, it's not have any of that. Google question J and K, what do you think the voltmeter would read now? That is actually trickier than you might think. Let's see if you're able to reason through it. It's easy once you know it. Let's see if you can figure it out. You might ask yourself actually to flip the order of these. K is easier than J. Everyone should at least do K. Let me put it that way. You can tell me a number for each of these, from 0 through infinity. Dahlia, the question is, tell me the voltage measurement that a voltmeter at point J would register. Put that in Google question J. For Google question K, I wrote K here. Tell me the reading that the ammeter would register. Use the principles that I just told you about how voltmeters and ammeters behave and what happens to current through them, or not. Better than usual. Again, let me encourage you to think about what we just said about meters and what you should have written in your notes at the top of the page. Google question L is designed to help you with JK. Google question L, read your notes and tell me, does a voltmeter allow current through it? Yes or no? Look at the top of your notes. So if a voltmeter, good. Yes, that is correct. No is the right answer. This is also my baby's favorite word. No, he says. The voltmeter, no, does not allow current to flow through it. So how much current must the ammeter register? That's the Google question K. You may adjust your answer this time. That's even better. Good. Good. The correct answer is the ammeter would register 0. If the voltmeter allows no current through it, it is effectively an infinite ohm resistor. No current could flow through the voltmeter, no current flows through the circuit. The battery is not flowing anything. These resistors are not feeling anything. Well, that's the next question. If there's no current being drawn. No, Dahlia, I didn't tell you the voltmeter yet. I'm going to guide you to understand it for yourself. If the current in the circuit is 0, my riddle to you is how much does voltage change through each resistor? Think about this. How do resistors change voltage levels if those resistors have no current through them? So are you telling me that the voltage at this point is the same as the voltage at this point? Correct? If there is no current through a resistor, it loses no voltage. If there is current through a resistor, V equals I times R. But if I is 0, V does not change. All right, so if this point and this point have the same voltage, what about this point? Well, 0, right? What's the voltage at this side of the voltmeter? What's the voltage at this side of the voltmeter? What does the voltmeter read? 24 volts. Turn to your neighbor and discuss why. Tell her why. You get an A. No. Nice. Okay. Questions now that you've discussed with your classmate. It reads all the voltage, but no current. Not because there's no voltage present, but because there's no complete path, Addison. The voltmeter blocks the current from flowing, and with no voltage flowing, no current flowing through the resistors, the voltage is indistinguishable from the voltage at the negative terminal of the battery. The resistors lose no voltage. You start with the battery voltage, you end with 0. Exactly, Isabella. It's reading the pressure. Nothing is flowing, but it still feels that pressure. Okay, so that circuit, I'm not telling you what I'm asking you, but that circuit, if you understand what we just did, you understand everything about, I think, 2 different questions on the test. Merry Christmas. Now here's another thing, and another thing, and another thing. I have taught you that a given resistor, if I buy a resistor, if I buy a 10K resistor, its resistance is 10K. That 10K resistor doesn't change its resistance without changing the resistor. That's how a resistor behaves. However, there are things that you can buy called variable resistors. That's a shitty name because variable resistors actually have constant resistance. And there's another component called a transistor that nobody but me calls this, but they should be called variable resistors because they have a variable resistance. You don't need to know about transistors and variable resistors yet. Let me simply tell you that there is a device that exists that can change its resistance. You turn a knob, and this guy's R changes. And the symbol is you draw an arrow through it. A diagonal arrow through these. I have a battery. I have a variable resistor. I ask you this. Increase the resistor's resistance. What happens to the voltage? Question, what are we on? M and N, right? M is if I increase the resistance of a variable resistor, change nothing else, what happens to the voltage across it? Question N is what happens to the current through it. Think carefully. Just because an equation exists does not mean you can apply it willy-nilly without thinking about what does what. For specificity, so you could discuss with your classmates, let's say I turn the resistor's resistance from 1 ohm to 10 ohms. I got a 9-volt battery connected to this. What happens to the voltage across the resistor? And what happens to the current through the resistor? By the way, you are always allowed to make up BS numbers for yourself if that helps you feel better. To reason about stuff. M, what happens to voltage? N, what happens to current as you turn the knob up? Hey, Cargill at asu.edu. Edit response or submit new. Edit your responses. You're appearing in my roster 15 times. Don't do that. Makes me think that nobody's answering the questions when half the class is doing. Okay, the correct answers are, well, hold on. Let me tell you how to reason about this. Memorizing sucks for physics. I've got an area. I've got a rectangle. Its area increases. What happened to its height? Turn to your neighbor. If I've got an area, a rectangle, length times height. I'm going to tell you A changes. What do you know about its height? I'm going to make A bigger. Does its height get bigger? Does it? Thumbs up, thumbs down. Does its height get bigger if I increase the area? The majority actually have it now. The majority are not voting, and that's correct. You don't know. Maybe the area, the width of the rectangle increases. Maybe the height of the rectangle increases. If I just tell you the rectangle's area increases, you don't know whether its length or height increase. You have to have some extra information. V does equal I times R. R increases. Does V change? Does I change? You don't know if all you know about is resistor. You have to think about the rest of the circuit, which is only one component, to answer this question. Turn to your neighbor. 1 minute. Should you change Mn? What is the defining thing about a battery that I have taught you? I'm never going to buy a 9-volt again. They're expensive. I'm just going to buy a 1.5 volt AA and increase its resistance attached to it. Yeah, right? 9 volts become 100,000 volts if you increase the resistance enough, right? Isn't that how voltage behaves? Your 9-volt battery can generate infinity volts if you just increase the resistance a lot? No! A battery? How have I almost defined batteries? What is the point of a battery? A battery keeps the voltage across its terminals constant. If you have a 9-volt battery, it's applying 9 volts to your circuit. Hint, hint, that's why I write 9 volts there. That's why I wrote 9 volts, not as first it's 9 volts, then you discover volts. It's a 9-volt battery, it stays 9 volts. The voltage does not change. Correct answer for M is the voltage does not change. V equals I times R. V does not change. R gets bigger. What must happen to I? Let's write this as a fraction. If V equals I times R and I solve for I get V divided by R equals I. Tell me what happens to a fraction when its numerator stays the same and its denominator increases. Google question O. What happens to fractions whose tops stay the same and bottoms get bigger? The fraction increases, decreases, stay the same. This is Google question O. Does the fraction get bigger or smaller as you increase the downstairs? I'm out of change. I'm going to give you guys a really good deal. Yeah? I'm going to give you 1/100th of a dollar. You give me 1/4 of a dollar back. I'll give you a penny, you give me a quarter. That's a good deal, right? You're getting 25 times more money, right? If I give you a 25th, if the downstairs goes up, doesn't that mean no. If the downstairs gets bigger, if you cut a pie into more pieces, the pieces get smaller. The correct answer is if V stays the same and R increases, I decreases. Which should also, if you have an intuitive sense that resistance is opposition to flow, make some kind of sense. If you increase the opposition, isn't there less flow? So, Google question M, you must know. You must know that if I have a circuit with a resistance that can change, increasing the resistance of the resistor does not change the battery voltage. But it does decrease the current delivered to the resistor. What if I have a series circuit? What if I have 2 resistors? Ooh, that's a lot of lines on here. What if we go back to our voltage divider circuit? Can you tell me what happens? Well, whatever, I'll leave the voltmeter on. Let's get rid of my green. It isn't easy being green, tells Kermit. Oh, for God's sake. Whatever. Doesn't matter. Tell me this. What happens if I make R2 a billion? If I make R2 a billion, does its voltage change? Does voltage change? Does current change? If I make R2 a billion ohms, if I make R2 a billion ohms, whoopsie, not in this circuit. This is the badly hooked up circuit. In the original circuit, I'm measuring current and voltage correctly. If I make R2 a billion ohms, does current flow if I give you a billion ohms of resistance in series? Is there current flow? What's the voltage across that resistor if there's no current through it? Times a billion. Well, how can we reason about this? I've got a billion ohms and I've got ignorably tiny ohms. Which of these is going to dissipate the 9 volts? Read the sentence that you wrote at the end of analyzing this. The fraction of the voltage across a resistor is proportional to the fraction of its resistance to the total. Which resistor is opposing the current? R2 is. The lower resistor, if this becomes a billion ohms, if the lower resistor becomes a billion ohms, that's the thing that's blocking up the pressure difference. That's the thing that feels 24 volts. A billion divided by a billion plus 6, right? Okay, so, if you change if you change the what? If you change the resistance of this resistor, of resistor 2, does the voltage across it change? We started at what? 9.6? I changed the resistance and it became 24? Does voltage change? Yes, absolutely. What about the total voltage? Does the total voltage change? No, absolutely not. The battery is the battery is the battery. The battery does not change its voltage depending on the current that is supplied. Actually, I'm slightly lying to you, but we'll talk about that later. The battery does not change its voltage, so the total voltage supplied to the circuit does not change. But that doesn't mean, don't just memorize that changing resistance doesn't change voltage. If you got 2 resistors, absolutely changes the voltage across one of the resistors. You actually have to think, though, about what is going on in the circuit. Do not rely on your memories. Rely on your reasoning. Memory is fragile. Reasoning is robust. This is how we avoid killing patients. If you think about what's going on, you catch mistakes. If you memorize procedures, when you're in your 23rd out of 24-hour shift, you kill patients. Right? If you don't think about what's going on. Okay, so the correct answer from what I just said is if I change the resistance, the voltage across that resistor might change, but that doesn't necessarily, the principle that we said before is true when you've got one resistor. If we're talking about the total resistance and the total battery, one simple circuit, changing the resistance doesn't change the battery. What about current in this circuit? If I make R2 variable and make him a billion ohms, does current change? Yes, absolutely. Current is changing. Does it get bigger or smaller? Smaller, just like before. If you increase series resistance in a compound circuit, voltage and current both change. Turn to your neighbor and discuss for a minute what's going on. What has Tucker said? Why has he said it? What's the point? What's the big idea? And then ask me a question. Ready, set, go. Don't let it wash over you. You can't get something if you just let it pass by. Question me before we move on. Don't hide your lack of knowledge. Show me so that I may fill it. Please, Mackenzie. Wait, louder. I am old and cannot hear. The voltage across a given resistor in a compound circuit may totally change when you change the circuit. But that doesn't change the battery voltage. If you have one resistor, changing its resistance does not change the battery voltage, does not change its voltage. It's connected directly to the battery. But if you have a multiple resistor circuit, changing the resistance of a part totally may. My point is you have to think about the why, not just memorize. Doesn't change voltage. Yeah. Makes more sense? Other questions, follow-ups? Congratulations. If you understand what's gone on, you got about a quarter of the exam just done in seconds. Yes. Don't sorry. I want you to make sure. Voltage from a battery will never change. Correct. The point of a resistor is to dissipate voltage, but don't say voltage going through a resistor. Voltage does not flow, current flows. As current flows through a resistor, the voltage is lost. There is a voltage difference. If I have a resistor whose resistance can change in a compound circuit, then the voltage present across that resistor may change. The current through both of those resistors in the compound circuit was changing, so the voltage across each of them must also change. Okay, last chance for other questions. Okay, I would like you to practice ratios. I am going to ask you a question that involves a ratio. What fraction of I1 is I2? I have given you enough information to find I1 and I2. You can find then the fraction of the total current flowing through the right resistor. Ready, set, go. And put this in Google question, whatever's next. What is next? P? Yeah, I do have to. Oh, yeah, that kind of P. Right, yeah. Google question P. Ooh, question. Wait, hold on. Good question, good question. Oh, I already answered that. Okay, so yes, tell me then, in this, what is the ratio of right current to total current? You could express it as a fraction, a percentage, whatever. Oh, for me to be able to auto-grade this, would you please express this as a decimal? Express the ratio, the fraction, the proportion of I2 to I1. Please give me a decimal, and then I can auto-grade. Dahlia, the challenge is find I2 divided by I1. And I will word this as what fraction of the total voltage, what percentage of the total current is I2? Ooh. Oh, no, crap. I changed the question and now everyone's got it wrong. Okay, here's how to analyze this circuit. Ready? I know the voltage, I know the current and the resistance to left resistor. What is that knee-jerk reaction if I know both I and R? Find the potential difference, find the voltage. What is it? 18 volts. What do you know about resistor 1 and resistor 2? They're in series or parallel? So what's the voltage across R2? Exactly. If I know, I didn't give you its value. I didn't give you its value. No wonder you're confused. What I will give you on the test, I will give you the value that this is a, will I? 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 I will. I will tell you that this is a 2 ohm resistor. There we go. Now the problem is solvable. I do sincerely apologize. Try that. I've just given a big hint inadvertently. Sorry? This could still be in P. Yes, expresses the decimal, the fraction, the ratio, the proportion, how much current compared to the total flows through the two. All right, how much current does R2 pass? How much current flows through the 2 ohm? Current in the 2 ohm. How much current does 18 volts generate when you have 2 ohms? 9? Yeah. Bilingual pun? No one? Okay, whatever. Correct. 18 volts present across a 2 ohm resistor. This 2 ohm resistor will feel 9 amps. Are those equal? Is 9 amps equal to 6 amps? Do unequal resistors split current evenly? Remember that. About half the class told me 50%. That's true if the resistors are the same resistor, same value. But in general, electricity prefers the path of less resistance. I've got a smaller resistor, it gets 9 amps instead of 6 amps, it gets more current. Okay, so you may use what I just said. 9 amps flows in the right resistor. You may change your answer for P. Tell me the ratio of the total. The ratio of that to total. Well, you have to decide how to find I1. I'm leaving that as your final task. Yes. Twenty. Yeah, I'm playing 20 questions with you. Yeah. Yeah. And you will have to have a Scantron, by the way. Yeah. From the bookstore. Sure. You have to. Yeah. Yeah. It's like 25 cents at the bookstore. Well, I mean, it's not ASU specific, but the model of they have different versions of Scantrons, and the one that my machine reads is go to this bookstore, by the way. This bookstore, not Tempe. You're a commuter? Yeah, yeah. So go to this bookstore and ask them for a pink Scantron. Oh, I should be telling people, I've never said this before, but if the thing gets all dog-eared, I have to manually grade it, and then I'm more likely to make mistakes and lose points. So please, for both of our sakes, don't let them all get ragged. Yeah. People just shove them into their backpacks, and the Scantron won't read that way. Yeah, or as few as possible.
Okay.
It will decrease the chance that it has to be hand graded. Okay, so 6 amps go this way, 9 amps go that way. How much current entered? Has to be 15 amps, right? I ask you this, what fraction of 15 is 9? 0.6 is correct. 0.6. Let me say this because, let me write this because math is hard to say out loud. 6 plus 9 equals 15 amps total. The question, which this is I2, the question is find I2, the total I called 1. If I ask you the fraction of the total, that is I2, I am looking for I2 divided by I1. If you plug in the numbers that we just found, 9/15 goes by the alternate name 0.4. Follow this procedure for whatever actually is on the test. Thank you. That was a test and she passed. I was just checking you. Isabella, it's 0.4 because I was thinking of something fabulous. It was you. That's weird. I'm sorry. I regret my life decisions. Okay? You feel okay with this now? Memorize this. No, don't memorize this. Think about this. What is the proportion of current that flows through this resistor? This was, in terms of ratios between the resistors, we've got a 9:6 ratio, a 3:2 ratio. Yeah, 9 to 6 is the same as 3:2. 3 parts of current for every 2 parts of current in the left. Hey, what's the ratio of the resistances? 2:3? If you've got a 2:3 parallel, then 3:2 measures of the current will flow through. That fraction will flow through. Do you see why? Okay. So that's another question. That's another circuit that you must analyze. Now let's see if you know series and parallel and how to add. For bonus points. No. Wait, I need to make an announcement. I need to make an announcement early and I need to make an announcement often. Before I give you values, you have 2 weeks, 2 weeks, 2 weeks to go to the ASU West bookstore and ask them for a maroon or pink or whatever they call it, Scantron. In those 2 weeks, you must gather up the funds of like 25 cents, gird your loins, go in there. You may have to skip lunch that day. I know you guys are shafted in this economy. Haha, only serious. So it's cheapo, but go in, pay your 25 cents, and please, if you wish not to be hand graded, which 1 annoys me, and 2 runs the bigger risk of missing points because I make a stupid mistake, if you wish to be graded by the machine, which always, I shouldn't say always, which 99.9% of the time grades things correctly, then don't just shove it in your backpack and let the sucker get all crinkle-crankled. Those Scantron machines are good, but they're not perfect. So if you take a little bit of care with it, you're less likely for me to hand grade it and you to end up losing points because I'm stupid. Take care of it. Maroon Scantron before the exam. I may bring some extra Scantrons, but I will publicly shame you for not listening to me with 2 weeks of advance notice. Okay, that said, Isabel shared a file in the meeting. I want to see the file. Wait, I don't get it. Oh, she's going to the Scantron. That's hilarious. I love it. 2 points for Isabella, or for Gryffindor, whichever comes first. Okay, so I got the record button now. It is recording. It is recording. Is it recording? I'm going to be all pouty if it's not recording. It is recording. Okay, okay. Okay, so, there is a symbol here that I have not explicitly taught you before. You may guess, but a squiggle means more circuit here. A squiggle up top means there's more circuit there. I'm giving you a bunch of resistors. I'm not giving you what else is connected. You don't need what else is connected. You could imagine that there's a battery connected between those terminals. You could imagine that there's Rush Limbaugh connected between those terminals. I don't care. It doesn't matter. The point is, this goes on, this goes on. There's other stuff out there. So that said, if I hooked an ohm meter up, if I looked at the resistance between these 2 points, you may need a calculator. You do not have to have a calculator, and if you are good at arithmetic, you don't need a calculator. But I will give you a calculator. I mean, I won't give you a calculator. You may use a calculator. I will not buy you a calculator. Find the resistance from top to bottom. What letter are we on? Let's see if you can do this in Q. What'd you call me? You want to fight? Just being silly. You may work together. Remind each other the formulas and the how to see stuff with your eyes. If the tildes bother you, there, it's connected to your face. We're going to practice this more. Okay, I've got like 5 correct answers. No, no, that's not okay. And I've got several people answering an R when it says Q up top. Okay, well, you know what? Whatever. Okay. I wish to point out, yeah, pro tip, MCAT students, you're not allowed to use a calculator, right? You are? No, no calculator. It may be useful to know arithmetic tricks so that you don't have to die doing long multiplication. I don't know what 1/130th plus 1/45th is. And I've got my PhD in fabulousness. I mean, physics. But I do know that if I express 30 and 45 as multiples of a least common denominator, 30 is 2 times 15, 45 is 3 times 15, or so they tell me. The product over the sum formula gets real simple, right? 15 over 15 dies, and I get 6 times 15 over 5. What's 15 over 5? 15 over 5 is 3. What's 3 times 6? Do you recognize what I was doing with that product over sum formula, by the way? Yeah, that's just the funky bunch resistor formula, the parallel addition formula. Okay, I will give you some more tricks and tips next time. The correct answer was 24. I'm sorry I ran over. I was just so excited. And I love you so much. The total resistance for everything is 24. 18 plus 42 is 60. 60 parallel 40 is 24. 18 is the equivalent of 30 plus 45. 30 parallel plus 45.